Good morning, folks. This is Mr. Walker here, coming to you with our next lessons. We've been talking about right triangles for a minute, but today we're going to learn about some special cases. Okay, so we got two different ones that we're going to be talking about. One of them is 45, 45, 90 degrees, and the other one is 30, 60, and 90. This is talking about the angles and how they're going to form up our triangles. We're still going to be using the Pythagorean theorem, so don't think that we're done with that. All right. So let's jump into it. Oh, hold on. All right. So let's talk about a couple things with this. These triangles are going to have certain lengths on them, and we will have to deal with radicals at some point. Now, the good thing about these types of right triangles is formulaic in method to deal with them. So that means that these will follow suit as we go through and dealing with their types of equations. Okay. So let's talk about our first types of right triangles. We're going to do a quick little investigation. So starting off, we're going to use these squares below to create a right triangle using a diagonal. So we're just going to cut each of these with a line diagonally from the top left to the bottom right. Let's look at the first one. All right, we got our square here. We cut that diagonally. We got the one in the middle, cutting that also by diagonally, and our third one being cut by diagonally. All right, things to notice, each of these squares, when we cut them on this diagonal, has shown us a triangle, and not just any triangle, a right one, because we see that we got some right angles here. Now, as we go forward, what are the measures of the angles in this triangle? All right, we know we got a 90-degree angle. Now, what we're doing is we're cutting on this diagonal, and this shape that we have originally was a square. Now, this diagonal here is going to go through and do one thing for us. It's going to take these angles over here, and also cut them in half. So what's going to happen is our measurements for these are going to be both 45, 45, and 90 degrees. These angles over here in the corner, so right over here and here, being 90, when we go through and take a look at the same ones over here that are also 90, if you were to just cut them straight in half, you would end up with 45 degrees and 45 degrees. All right, let's jump a little forward. Let's find the lengths of each of these diagonals. So, things to be aware of. If we're dealing with the square, you know that all of the sides are going to be equal. Thank you. So, if all the sides are equal, that means that down here, this is one. Over here, this is also one. Down here, two. Over here, two. Over here, we got three. And down here, we also have another three going for us. So we're going to run the Pythagorean theorem to find out what this length is in the middle of each of these triangles. All right, let's go through. We know that this is c squared equals a squared plus b squared. For the first one, we got our a and b's are both 1. We got 1 squared plus 1 squared, which is 1 plus 1. 1 plus 1 is 2. So c squared equals 2, which means that c equals the square root of 2, because that would be the only thing that's left. We got to take the square root to get c by itself. Now, getting c being the square root of 2, let's see how this is going to work for these other two bigger triangles. All right, one in the middle. We also got c squared equals a squared plus b squared. We got 2 squared plus 2 squared. That's 4 plus 4 gives us 8. 8, when we go through and take the square root of it, it's not a perfect square, which means we have to simplify this in simplest radical form, being 2 radical 2. All right, let's check the third one. Same stuff's going to be following suit. We got c squared equals a squared plus b squared. Down here we got c squared equals 3 squared plus 3 squared, which is 9 plus 9, which is 18. Taking the square root of that is also not a perfect square, so we got a simplest radical form and simplify, which means that we get 3 in the square root of 2. Things to notice, you've seen that there is a radical on each of these numbers, and that radical is the same. Next thing to notice, in front of the radical, the number that we have is also something that we've seen from earlier in the problem. In front of this radical, even though we don't see it there, there's a 1 that is there. Just like how over here we have this 2 and this we have the 3. These 3 are the sides of our right triangle. So, that being said, things that we should notice, we are going to be noticing that this length of the hypotenuse is going to have some square root of 2 involved, plus it will have whatever the lengths are of the sides popping up in front of it. See, in the middle, we got 2 and 2. 2's in front of our radical 2. Over here, we got 1 and 1. The 1's in front of our radical. Over here on the right, we got 3 and 3, which means that we got a 3 in front of the radical. Okay, so you got to make sure that you go through and deal with that as you are going through this part. So let's take a look at the triangle that we're going to be talking about in particular, which is the 45, 45, 90-degree triangle. So 45, 45, 90 means that we have a 40-degree angle, a 45, sorry, not a 40, a 45, a 45, and a 90-degree angle inside of the triangle. So in this type of triangle, the hypotenuse is the square root of 2 times the lengths of the leg. So whatever the leg is, you have square root of 2 times that for the hypotenuse.